Here we're going to talk about how to find the volume of a rectangular prism. And a rectangular prism is really just a box. You can think of it that way. And remember, with volume, you can think of it as filling something. So if you have a swimming pool, a rectangular swimming pool, and you're trying to fill it with water, that is volume. How much water do you need to fill it? You're calculating the volume. So volume comes with three-dimensional objects, whereas, for example, area, you can think of painting a surface for area, and then perimeter, you think of, like putting a fence around something. That's perimeter. So with volume, you can think of it as filling. And all the units for the volume problems will be in cubic units. And so if you see a problem where the answers are cubic, you know you're doing a volume problem. If you look on your formula sheet, you will see the formula for the volume of a rectangular prism, and it's V equals LWH. Volume equals L stands for length, W stands for width, H stands for height. And remember, when you have three variables next to each other, that means multiplication. So it's volume equals length times width times height. So again, a rectangular prism is just a box. So let's say we have a box like this, and this is not going to be drawn to scale, but let's say we have 10 feet by 7 feet by 3 feet. So again, not really drawn to scale. And it asks, what is the volume of this rectangular prism? All you do, pull out your formula sheet. Volume equals length, which is 10, times width, which is 7, times height, which is 3. Put that in your calculator, you get 210. This is in feet, and so the answer will be feet cubed. I'll write that a little bit better. So cubed is, it has a 3 for the exponent, because here you're doing 10 feet times 7 feet times 3 feet. So you're multiplying 3 feet together, so it's going to be feet cubed. So again, if you are doing a multiple choice question and all of the answers have a cubic unit on them, you're probably doing a volume question. Okay, so that's pretty straightforward. You just multiply the numbers together. Let me show you something similar but a little bit trickier, just to be aware of. Let's say you are building a driveway and you want to pour some concrete, and you need to know how much concrete you need. So your driveway is 25 feet in length, 16 feet in width, and 6 inches in height. So you have this long driveway and its width, but then the concrete for the driveway is only 6 inches tall. So again, not drawn to scale. So how much concrete do you need? What's the volume of this? So be careful when you're doing these problems, really any sort of geometry type problems, area, perimeter, volume. Here you have feet, but here you have inches. And so you can't multiply feet and inches together. They all have to be the same units. So you can either change everything to inches, or you can change everything to feet. Since we have two numbers in feet, we're just going to, for this one, we're going to change it to feet. So we have 25 feet, 16 feet. How many feet would 6 inches be? Well, we know that there's 12 inches in a foot, so you definitely need to know that. So 6 inches, all you do is take your inches and divide by 12. That's how many feet you're going to get. So 6 divided by 12 is 1/2. And you can write that as a decimal. 1 divided by 2 is 0.5. So 6 inches is 0.5 feet, or half a foot. So now we can again just get our formula sheet out. 25 times 16 times 0.5. And if you do that, you're going to get 200 feet cubed. Okay, so just be careful. If they start mixing units, you need to make sure they are all the units, because remember, in the answer it's feet cubed. So if this is inches, then that doesn't make sense. Similarly, if you'd rather make all of these inches, you just multiply these by 12. So you're going to end up with larger numbers, but you'll end up kind of the same with the same concept. Okay, we're going to do a little bit more involved problem now. So let's say we have blocks, toy blocks. So all of the edges have the same length. So we have these blocks, and each edge is 2 inches. So this is a perfect cube. Each edge is 2 inches. It's 2 by 2 by 2. And we are going to put it into a bigger box, like a little toy box. And so the toy box, we're going to say, is 8 inches by 6 inches by 4 inches. So again, not drawn to scale, but just look at the numbers. And the question is, how many of these little blocks can fit into the toy box? And so I'm going to show you 2 ways to do this. One is just using logic. So if you get into the test and you just cannot remember anything about volume or anything, you can figure this out logically. So I want to show you how to do that first, and then we're going to do it the mathematical way using the volume formula. But if it says how many of these blocks can fit into this, all you need to do is think of it logically, because often on the test, if you just think through it, you'll be able to figure it out. So if we have 2 inches, the block is 2 inches, then across the bottom here, we can put 1, that'll be 2 inches. We can put another one for another 2 inches. We can put another one, another 2 inches, and then one last one. So there's 2 inches, 4 inches, 6 inches, 8 inches. So we can get 4 blocks across the bottom. Widthwise, we can get 1 block, and that will be 2 inches. We put another block, that's another 2 inches, and then a third block, because you have 2 inches, another 2 inches would be 4 inches, and then another 2 inches would be 6 inches. So if we are now looking down on the toy box, like we're standing over the toy box, and we're looking at the floor of the toy box, you can see that we can fit 1 block in the corner, then another block, another block, and another block. We can fit 4 this way, because remember, these are 2 inches, and these are 2 inches. And then we can do the same for the next row, and then we can do the same for the third row. So we're looking down into the toy box, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We can fit 12 blocks on the bottom of the toy box. So that's 1 row of blocks on the bottom. Well, it's 4 inches high. Remember, one of our blocks is 2 inches high, because it's a perfect cube. So we're going to fill half of the box with this 1 row, right? We're going to have 1 row of blocks on the bottom. Then we can fit a second row on top of that. So a second row of 12 blocks, we would have a total of 24 blocks. So that's just a way to kind of figure it out logically. Just think, okay, how many blocks can I go this way, and then how many blocks can I go this way, and then how many can I stack on top of each other. Now, let's try and do this mathematically. Remember, we got 24 blocks total. So, in order to figure this out using volume, you first find the volume of the larger box, of the toy box, and that is, the volume of the toy box is 8 times 6 times 4, which gives you 192. inches cubed. And then the volume of one block, so this is of the toy box, this is of the block, is 2 times 2 times 2 equals 8 inches cubed. So how many of these go into the larger box? You just divide the larger box by this. So the volume, or sorry, the number of blocks is 192 divided by 8, which gives you 24 blocks. And remember, that's the same answer we got when we were trying to just figure it out logically. So all we did, we found the volume of the larger box, we found the volume of the smaller one, and then just divided this divided by that, and it'll give you how many blocks will fit in there. I'm going to take a pause and put up one final question. Okay, we're going to do one final question kind of quickly, but this might be the type of question that you will find on the test as well. So here we have two boxes, box A and box B, and their dimensions are up here, and their dimensions are fairly similar, except box A has a bit shorter length than box B. And the question is, what is the ratio of the volume of box B to box A? So here you need to know how to work with ratios. So if you don't know how to do that, you need to watch that video. So that's why I'm not going to go through this in detail, because you can watch the video on ratios. But I just want you to know that this type of question is probably common on the GED test. So what's the ratio of the volume of box B to box A? Well, of course, we need to find the volume of box B and the volume of box A. Volume of box B, length times width times height. You get 360 feet cubed. Volume of box A, length times width times height, 300 feet cubed. What is the ratio of the two volumes? So in order to write a ratio, you can either do that as a fraction or with a colon. We're going to write it as a fraction first. So the ratio of volume of box B, well, the volume is 360 over the volume of box A, which is 300. And then you put this into lowest terms. And if you don't know how to do that, you need to watch the video on lowest terms. But we're going to first divide it by 10. That seems pretty obvious. You get 36 over 30. And then we'll divide that by 6. And you get 6 over 5. So the answer to this question, whoops, let me write that so you can see it, is 6 over 5. Or if they write it this way, it's 6 to 5. So just be aware, they kind of like these ratio questions, but don't let that throw you. Just know how to do ratios, so go watch that video, just calculate the volume, and then you put them in a ratio format.